So this is a picture showing the depolarization of a muscle cell. So we need to know that when a stimulus comes and stimulates a cell, there is reversal of the polarity. The cell which was negative inside will start to become positive from inside and vice versa from the outside. The arrows here are representing the advancing vector of depolarization, and this is also called a dipole. Now why this is also called a dipole? Because if you see this arrow is actually made up of a negative pole and a positive pole. The arrowhead represents the positive pole and the tail is representing the negative pole. It is basically telling you the direction of the movement of positivity inside the cell. Okay, that means the positivity is moving towards the right side. Okay, in this figure. So if you see in this figure, you will see that this is where the positivity is moving. The cell is becoming negative to positive as we move from this side to this side. Okay, so this is the advancing vector of depolarization, which is a dipole. Dipole means that it has two polarity, a negative and a positive one, and the arrowhead always represents the positive polarity in this case. Okay. Now, if we carefully see the figure B, it has a lot of concepts. Now, we need to understand that when the current flows towards an electrode, it's gonna give you a deflection. Okay, it will give you a deflection. It could be a positive deflection or it could be a negative deflection. Now, we need to know that when the positive side of the dipole faces a recording electrode, now this is a recording electrode number 1 and this is the recording electrode number 2. Now when the positive side of the dipole is facing an electrode, this electrode will record a positive deflection. And if an electrode faces the negative side of the dipole, just in case this side, just in this case, so it will record a negative deflection. Again, if the positive side of the dipole is facing a recording electrode, that recording electrode will record a positive deflection. And if the electrode is facing the negative side of the dipole, just in this case, it will record a negative deflection. So this is a very important concept and we will be continuing this one further in case of repolarization. Okay, so this is the image representing the repolarization of a single muscle cell. We just did depolarization of a single muscle cell. Now it's time to do repolarization. Now we need to know this thing that the part of the cell which depolarized the first is the one that will be repolarized the first. Okay, so we know that in the previous figure this was the site which was depolarized the first. Okay, and this will be the site which will be depolarized the first. And the reason for that being is that the side of the cell that depolarized initially will have enough time to recover. Hence, it's gonna undergo repolarization initially. So if you see in case of repolarization, the cell is getting back to negative again, just like it was in the resting phase. And that is what repolarization is all about. It's gonna bring the cell back to its normal resting phase. So definitely in that process, the positivity inside the cell will be converted into negativity. Okay. Now, if you carefully see this time, the direction of the advancing vector or dipole is the same as that of the depolarization, but now the polarity is different. In the repolarization vector, if you see, the head is represented by the negative charge and the tail is represented by the positive charge. Whereas in case of depolarization, we saw that it was opposite. Okay. So the advancing vector in case of repolarization will be formed depending upon the direction the negativity is moving. In case of depolarization, the advancing vector or the dipole will be formed depending upon the direction in which the positive charge is moving. Okay, so the head is actually going to define you the direction of the negativity or the positivity. Coming to the figure number 2, now this was the depolarization vector that we've already recorded. Okay, now we will see how do we record the repolarization vector, how do we record the repolarization activity of a single muscle cell. Now if you see here, the dipole is having negative charge on the right side and positive charge on the left side. Again, we know because the repolarization was moving from left to right. The negativity was moving from left to right. This is the reason that the head is having negative charge and it faces towards the right side in this case. So if a recording electrode is facing the negative side of the vector, it will record a negative deflection, just like we did in case of depolarization. And if the recording electrode is facing the positive side of the dipole, it will record a positive deflection. So this is the reason why, if for example we're going to consider it as R wave or T wave here, this side would be negative and T wave here would be positive. So the very last time, why are we having a negative deflection here and a positive deflection here in case of repolarization? The reason for that being is that here the recording electrode, which is this one here, is facing the negative side of the dipole. Hence, it will record the negative deflection. Okay, and in this side, if you talk about on the left side, the recording electrode, which is the electrode number 2, is facing the positive side of the dipole. Hence, the deflection will be positive. So this is the reason that we have the negative and the positive deflection respectively.